In the last class, we completed the uniform plane wave in free space, and we derived the expressions by using the Maxwell's equations, modified Ampere circuit law, and Faraday's law, del cross H bar and the del cross P bar. By using those two equations, we derive the equations of dou Hy by dou Z is equal to, and dou by dou T of Hy is equal to the two functions. So one equation is dou by, let us see here, the dou by dou Z Hy is equal to. So this is the equation we got from the modified Ampere circuit law, del cross H bar is equal to the minus epsilon naught into dou Ex by dou T. Dou Ex by dou T. So the relation of magnetic field and the electric field. And similarly, by using the Faraday's law, del cross E bar is equal to minus dou B bar by dou T, we derive the one equation dou Hy by dou Hy by dou T is equal to Hy by dou T is equal to minus 1 by mu into dou Ex by dou Z. Okay. So actually it is a dou by dou Z of Ex is equal to mu into dou by dou T of Hy. Actually it is minus of. So in the left hand side you can see the both are, it is a magnetic field Hy, and in the right hand side you can see the both the equations are the Ex, electric field, and there's a multiplication factor here, the minus epsilon naught and the minus 1 by mu. And also using these two equations we derive the another expression, the V is equal to the velocity of the light. V is equal to, in terms of permeability and the permittivity, mu epsilon under root. V is equal to 1 by the under root of mu epsilon naught. How it is? You can take dou by dou T of dou Hy by dou Z, the dou both the functions, is equal to epsilon into dou square Ex by dou T square. So one time we can multiply this dou by dou T, and it becomes of dou square Ex by dou T square. And second equation you can apply the derivative with respect to the Z, dou by dou Z. It becomes of dou square Ex by dou Z square. So in the left hand side, both the equations is with respect to the Z and with respect to the T of Hy. Equating these two equations, dou square Ex by dou T square and dou square Ex by dou Z square, and minus into minus plus mu epsilon. Okay, minus into minus, it becomes of the plus, and dou square Ex by the dou T square is equal to 1 by mu epsilon dou square Ex by dou Z square. So it is equal to the V square is equal to actually the 1 by mu epsilon naught. 1 by mu epsilon naught. So V is equal to 1 by under root of mu epsilon naught. The mu and mu naught is in the free space. Mu r is equal to 1, and epsilon naught in the epsilon, it is epsilon r is equal to 1. Now, we can take the mathematical expression of Ex is equal to having the two terms with the cosine functions Em plus cos omega t minus Bz beta z, and plus Em minus and cos omega t plus beta z. Okay. The same fashion, hx hy is equal to E is in the x direction, h is in the y direction. So hy is equal to, having the two terms with hm plus cos omega t minus beta z and minus hm minus cos omega t plus beta z. So this equation is a ohms per meter, volts per meter, and amperes per meter. The units of electric field, volts per meter, and the units of magnetic field, amperes per meter. Electric field is in the default is actually the x direction, and magnetic field is default in the y direction. Okay. So using this equation, dou by dou z of hy is equal to minus epsilon naught into epsilon into dou ex by dou t. You can substitute this one in this first equation to get dou by dou z of under dou by dou t. You can take it is one. Second equation, hy is equal to minus 1 by mu into dou by dou z of take the ex, whatever the ex is there in this second equation, you can substitute this ex value. Em plus cos omega t minus z minus beta z and plus Em minus cos omega t plus beta z. So in the right hand side with respect to the t, and in the left hand side with respect to the t of magnetic field, and in the right hand side with respect to the z electric field. So Em plus is a constant and Em minus is also constant. Dou by dou z of this function cos omega t minus beta z. The derivative of cos is a sign. The derivative of the cos is a minus sign, and here the minus beta z, the omega t is a constant, the minus beta z is there, we'll get as a beta value. Okay, let us see, I will write this equation, 1 minus 1 by mu Em plus is a constant. Now applying dou by dou z of cos function. Dou by dou z of cos function, it is a minus value, minus sine, whatever the term is there in the parenthesis, you can write it as that one, minus beta z. And also you can apply with respect to the z, means what is the coefficient of z here, the minus beta. So look at the minus beta into also. Okay, this is a total function for this dou by dou z of cos omega t minus beta z plus. Similarly for the second term also, you can apply that with the Em minus the cos function. The cos derivative is a sine, minus sine. Minus sine omega t plus beta z, omega t plus beta z, and you can apply that z coefficient also. Now here it is a plus beta. Okay, is a total function of dou by dou z is equal to, again I am writing this one, minus 1 by mu into the coefficient is a Em plus, so see here the minus and the minus is a plus, beta into sine omega t minus beta z, that is the first term, and here the minus is there, plus into minus is a minus, the coefficients are Em minus into beta, Em minus into beta, and the term is there, the sine function, sine omega t plus beta z. Okay, Now in the right hand side, we got it is a EM plus and the beta. And minus EM minus into beta. Now both the terms in terms of in the sine function. In the left hand side, the dou by dou t of hy is equal to the right hand side. You can apply the integral. Now the left hand side, you can apply the integral with respect to the t. With respect to the t, you can apply the integral on both sides. Then it becomes of hy is equal to okay. Apply the integral now. Now applying the integral. So integral on both sides with respect to the t. So minus 1 by mu em plus beta, the integral of sine function here is a cosine, minus em minus beta, the integral of sine function is a cosine function, and internally we have the t coefficient is a omega. You can now divide with that omega, the beta by the omega will get. Okay, let us see here. Hy is equal to minus 1 by mu into the first term having the em plus beta, the integral of sine function becomes of cos omega t minus beta z, and the t coefficient is a omega. Then minus, you see here the second term having the minus is there. Em minus and beta. Now I can apply the integral of sine function is a cosine, cos omega t plus beta z whole divided by the omega. Why I'm writing the word divide by? Because we are applying here the integral. Okay. So now the minus 1 by mu into em plus beta by omega. Okay. So before that, you can directly write that beta by omega and beta by omega. On both terms, there is a beta by omega. I am writing this as a beta by omega mu. Okay. Em plus cos omega t minus beta z minus em minus cos omega t plus beta z. Okay. Again, you have got the same function, that is a em plus cos omega t minus beta z and minus em minus cos omega t plus beta z. Assuming this, the total function as hm plus hy is equal to, I am rewriting this function as already I wrote here, equating this function hy is equal to hm plus cos, hm minus cos function, hm plus cos omega t minus beta z minus hm minus cos omega t plus beta z. Now equate these two functions. What is a hm plus now? Hm plus is equal to minus beta omega mu em plus, and hm minus is minus into minus is a plus here, em minus beta by omega mu. Okay, hm plus is equal to, now I'm writing here, hm plus is equal to minus beta by omega mu into em plus. Okay, and the same function here, the minus is there already, the minus. So now I'm equating this function, hm minus is equal to the same beta minus beta by omega mu minus beta hm minus is equal. HM minus is equal to minus beta by omega mu EM minus. Okay. Now the ratio between of a magnetic field and the electric field, or electric field by the magnetic field, is nothing but intrinsic impedance. Intrinsic impedance. EM plus by the HM plus is a eta, or EM minus the HM minus is a minus value. We'll get omega mu by the beta. Omega mu by the beta value. Now let us see. The eta is equal to, eta means intrinsic impedance. Is a ratio between of electric field and the magnetic field positive coefficients EM plus, or it is also equal to minus of EM minus by HM minus. In both the equations, you can see here, that is the first one, EM plus by the HM plus. Cross multiply this EM plus HM plus omega mu by the beta. Okay, omega mu by the beta. Even if you can take this also, the negative sign is there. That is also omega mu by the beta. Eta is equal to omega mu by the beta. So what is the omega by beta is already know the velocity. Velocity V is equal to is omega mu under root, so equal to omega by the beta. Omega by the beta value. Now the eta is equal to, is one of the equation. Eta is also equal to the omega mu by the beta. The omega by beta is a V into mu. Okay, V into the mu values. We derive the expressions. Velocity V is equal to velocity, propagation velocity, the velocity of propagation, or also call it as a wave velocity. V is equal to, the two formulas are there, 1 by under root of mu epsilon, not the mu epsilon, omega, no, not the omega mu, it is omega epsilon, my dear students. So wrong I wrote, omega epsilon, or it is also equal to the omega by beta, and intrinsic impedance omega mu by the beta, where intrinsic impedance is the ratio between of EM plus by the HM plus. EM plus by the HM plus. We'll get to omega mu by the beta, and omega mu we can return as in terms of the velocity V is equal to V into mu. Okay. The V is equal to 1 by root, these are approximately equal to 3 into 10 to the power of 8 meters per second. Okay. Another way, the velocity V is also represented as F lambda. So lambda is equal to 2 pi by beta. You know, this is the equation we use in the transmission line, the 2 pi by the beta. Now, multiply the F on both sides. So lambda F is equal to 2 pi F by the beta. What is a 2 pi F means? Angular velocity frequency omega by the beta. What is the omega by beta? Is a velocity V. Okay, velocity V. So V is equal to F lambda. V is equal to F lambda. This is one of the equation. Or we can write directly here. It is F lambda. For velocity V, the wave velocity or the velocity of propagation, V is equal to 1 by epsilon mu. That is also equal to the omega by beta, and that is also equal to F lambda. And intrinsic impedance is the ratio between of electric field and the magnetic field of positive coefficients or the negative coefficient with the negative sign. From that we got omega mu by the beta, or you can substitute the omega by beta as a velocity. The intrinsic impedance is also equal to mu V or V into mu. Okay. And also it is equal to that. You see the eta is equal to V what is a V? 1 by the root of epsilon into mu into V into mu. So here the under root of mu is there. There it is a x. X by root x is the root x. That is equal to under root of epsilon, not the epsilon, mu by epsilon. Is another equation we got for the intrinsic impedance. Eta is equal to under root of mu by epsilon. You remember this, all the functions, and if you can substitute the mu naught is 8.854 into the power of minus 12, and epsilon is 8.854 into the power of minus 12, and mu is equal to 4 into the power of minus 7, and simplify this, we'll get the 120 pi. 120 pi, or it is a 377. This equation is 120 pi, or it is also equal to the 377 ohms because it's the impedance, intrinsic impedance. The velocity is the 3 into 10 to the power of 8 meters per second. You substitute the mu is equal to 4 pi into 10 to the power of minus 7. Epsilon is equal to 8.854 into the power of minus 12. Simplify that, the velocity will get approximately equal to the 3 into 10 to the power of 8. Okay. Now you can find out the wave equations. The wave equations are the gamma is equal to. So what is the gamma? The propagation constant. In that the propagation constant gamma is equal to alpha plus I beta. So what is alpha there? Alpha is nothing but attenuation constant, and beta is a phase constant. The wave is propagated through one medium to the another medium. The electric field is in x direction and the magnetic field in y direction. The wave, electromagnetic wave, is in the z direction. That wave is propagated through the medium. Through the mediums, one medium to the other medium. From dielectric to the conductor, there is no any transmission in the conductor. All that is the instant beam is reflected. Transmission is 0. Only having the reflection coefficient only. If we consider the mediums in between of dielectric and dielectric, for incident beam, nothing but is electromagnetic wave is propagated in the z direction to that mediums, dielectric medium and dielectric medium. Some part is transmitted in the dielectric 2, and some part is reflected in dielectric 1. So in the left hand side we consider it as a medium 1, and right hand side we consider it as a medium 2. One time if taking the dielectric and conductor, another time we can take the dielectric 1 and the dielectric 2. There is some parameters are there. In the dielectric 1, the parameters are epsilon 1, mu 1, eta 1, and V1. Okay, the eta 1. Eta 1 is the intrinsic impedance, the dielectric constant. Epsilon 1 is also the dielectric constant 1. And mu 1 is also the dielectric constant 1. And the conductivity is also sigma 1. These are the parameters are there in the one medium. And in another medium, the parameters are the same parameters. We can call it as a dielectric 2, epsilon 2, mu 2, sigma 2, and the eta 2. And if it is a velocity is there, that velocity is a V2. Okay, using these equations, we derive the equations of velocity of 3 and intrinsic impedance is the 3. Omega mu by beta and V into mu, and eta is equal to under root of mu by epsilon. And velocity V is equal to 1 by under root of mu epsilon, that is equal to omega by beta. And it is also equivalent in terms of the wavelength, frequency into wavelength f lambda. Remember this, my dear students. These equations you can remember. Then you go for to find out the propagation constant. Propagation constant. That propagation constant gamma is equal to, in that what is alpha value and what is the beta value. Let us take the same Maxwell's equations. The Faraday's law, the first Maxwell's equation saying that del cross E bar is equal to del cross E bar is equal to. Listen carefully, my dear students. This derivation is very important. What I told now, the previous this derivation, how to find the intrinsic impedance and how to find the velocity. and how you get the velocity in terms of the wavelength. It is a very important. And now this also is a very important to find the propagation constant gamma in terms of alpha and the beta. Let us first, we can take the Maxwell's equation. Del cross E bar is equal to minus dou by dou T of B bar. Minus dou by dou T of E bar. Okay. What is a B in terms of H is minus mu into dou by dou T of H bar. Dou by dou T of H bar. Since the B is equal to mu into H, you know, electric flux, not the electric, magnetic flux and the magnetic field. Apply the del cross on both sides. Del cross of del cross E bar is equal to and minus mu, this is a constant, del cross dou by dou T of H bar. So for this equation, I am applying on both sides with the del cross to del cross. We know the del cross E bar upon the curl properties, del of delta T bar. We use this to find the Laplace equation, the cosine equation. Del of delta T bar minus del square E bar. Del square E bar is equal to, this is a total del cross E bar is nothing but del of, these are one of the property in the curl function. Cross is nothing but curl, dot is nothing but dot product only. Nothing, del of del dot E bar minus del square E bar is equal to minus mu. I'm taking this dou by dou T for total function, dou by dou T of del cross H bar. Del cross H bar. Okay. So according to the Maxwell's equation, the second Maxwell's equation saying that del cross H bar is equal to modified Ampere circuit law, my students. Modified Ampere circuit law, del cross H bar is equal to JC plus JD. What is a JC? Minus mu into, I'm applying the dou by dou T of, listen carefully, dou by dou T of del cross H bar. This is the Faraday's second law, not the Faraday's second law. Maxwell's second equation is modified Ampere circuit law, JC plus JD. JC plus JD, where JC is the conduction current density and JD is the displacement current density. Minus mu dou by dou T of JC is sigma into E bar plus JD is dou by dou T of D bar, and that D I am writing it as a in terms of E bar, epsilon into E bar. So dou by dou T of D bar it is actually. And that is equal to, and we know the del dot E bar, on the del dot D bar, we substitute is a 0, del dot B bar is a 0. So first term is becomes of the 0, we have only the second term, which is 0 minus del square E bar, and it is a minus del square E bar. The minus into minus becomes a plus there, cancel that one, del square E bar is equal to. Now the dou by dou T can substitute as a j omega. That is a fourth table in the Maxwell's equation, my dear students. That is dou by dou T becomes of j omega minus mu into, instead of writing that, it is a j omega here, dou by dou T into sigma into E bar plus, again the dou by dou T is here, replace the dou by dou T with j omega epsilon into E bar. We know this, how we get the j omega. D is equal to D naught into j omega, apply the derivative, and second time we get the j omega term. Okay, and the del square E bar is equal to del square E bar is equal to the first term you can see minus is not there, my dear students. Here already the minus and minus becomes a plus, no need of this minus. Okay, in both the terms E bar is a common, E bar into, let's see again, in these two terms j omega is a common, j omega, and what is the remaining in the first term, j omega mu. Is there any mu here? Okay, you can multiply, then you can use that one. See, you see, multiply this one, the first term, sigma mu j omega E bar plus, and again mu j square omega square epsilon into E bar. Now you can take the terms. Del square E bar is equal to, then you can understand. E bar is a common term, so E bar. Then after j omega is there and mu and j omega mu. Take total term as a j omega mu is a common term. In that, multiply that. What is the remaining? J omega mu E bar is gone, and sigma plus, and one j omega got there, and E is also there, and sigma j omega epsilon. J omega epsilon. Okay, is a term. So del square E bar is equal to E bar into j omega mu sigma plus j omega epsilon. And similarly for magnetic field also you'll get the same thing. Del square H bar is equal to, how it is, you can take the first of all del square H bar is equal to JC plus JD and simplify this function and apply the internally the Faraday's law. Finally you'll get in terms of the H bar. Del square H bar is equal to H bar into the same function, j omega mu into sigma plus j omega epsilon, even for del square H bar. Taking this del square H bar is equal to JC plus JD and apply the both sides, the del cross E bar is equal to whatever we got here, the del cross H bar, there we'll get the del cross E bar. The del cross E bar is, you can substitute the minus dou B bar by dou T and simplify, you get the same equations. Del square E bar is equal to and del square H bar is equal to, where the functions whatever is there in the parentheses, j omega mu sigma plus j omega epsilon. And this is the equation we have. Del square E bar is equal to, that is gamma square into H bar E bar, or otherwise when it is in the magnetic field, del square H bar is equal to, it is gamma square into H bar. What is a gamma square now? Whatever the parenthesis there in the top, and let us see that also. Gamma square is equal to j omega mu sigma plus j omega epsilon. Okay, or gamma is equal to under root of j omega mu sigma plus j omega epsilon. This is a propagation constant. Gamma is equal to, or it is also equal to the alpha plus I beta, where alpha is attenuation constant, and beta is a propagation phase constant. Understood, my students? So from this we can find out what is alpha is equal to and what is a beta is equal to. One plus sigma by omega epsilon whole square minus 1 is all multiplied this. Okay, is a mu. Mu epsilon. And beta is also omega under root of mu epsilon by 2 and whole multiply with under root of 1 plus sigma by omega epsilon whole square is under root only for this function plus 1. Okay. By simplifying this, gamma is equal to j omega into sigma plus j omega epsilon, you get the alpha and the beta. That also you can derive this function, how we get this function alpha is equal to beta is equal to the lateral. And we know the eta is equal to, the eta is the sigma plus j omega epsilon by the j omega. That is EM plus by HM plus, the ratio between of the electric and the magnetic field as a positive coefficient and the negative sign with the negative coefficients. In terms of omega, mu and the epsilon value, it is a sigma plus j omega epsilon and whole divided by j omega mu. Okay, that is a formula for the eta. Now, if I am considered it as a conductor, the conductor is very high. Whenever there is a boundaries between the dielectric and the conductivity is very high. So only we have the numerator is a sigma by the j omega epsilon. And here also the conductivity is a more, means gamma is equal to j omega mu. There is no any term of the j omega epsilon. The dielectric constant is negligible. Suppose if it is a dielectric, the conductivity is a 0. Okay, if it is a perfect dielectric, means epsilon is there and sigma is ignoring, or the sigma is equal to 0, and is a perfect conductor, sigma is there and epsilon is, assume it is a 0. Now see, if it is a dielectric, we already derived the equations for the eta is equal to, see the eta is under root of mu by epsilon. This equation we got from the uniform plane wave in free space. Uniform plane wave in free space. Free space means it is a dielectric. Dielectric means what is the conductivity is a 0. In dielectric, let us see, in dielectric, sigma is equal to 0.